And welcome everybody. Welcome to this morning's webinar on the warmer home scheme ventilation. Just to stress, this morning's webinar is focusing in on ventilation and the warmer home scheme. I know there might be some attendees from other schemes as well, and there may be some slight differences to the rules across the schemes. But this morning we're focusing in on the warmer home scheme. So I'll just share my screen. So just to kickstart, as I said, welcome everybody again, and we're hoping that this will be the first in a series of webinars looking at contractor quality and supporting contractors in improving quality, and looking at the data at what's driving our reworks, and producing some webinars that might support contractors in improving them. So the first slide today is where we had done a bit of analysis looking at contractors' quality versus their output. And what the slide is showing us, I think it's an interesting slide, is the chart on the left is showing us a contractor who over the course of 2022 has increased their output on the scheme, but as a result you can see that their average penalty points has also went up considerably. So there's a strong correlation there between the drop in quality and their increase in output. Whereas the chart on the right is showing our top 10 contractors in relation to output, and while there might be some contractors within that 10 that are similar to the contractor on the left, overall there's little or no correlation between the increase in output and quality, which is what we would hope to see. So the next question then is, what's that telling us, and why would we think that is? And what that's really telling us is where contractors who have, I suppose, good project and quality management systems in place, that they support the contractors in increasing their output without sacrificing quality, which is what we would hope to see. So over the next couple of weeks and months, we'll be reaching out to contractors and supporting them where we see that they're having difficulty in improving their quality management and project management systems that will allow them to increase their output whilst maintaining quality. So again, moving on. So today then what we're focusing in on is ventilation. And why are we focusing in on ventilation? So again, we've done some analysis, which we'll go through in the next couple of slides. But when we've done our analysis, we can clearly see that external wall insulation generates the highest number of penalty points, even when we remove the ESB points. So there's over 1,400 penalty points identified in 2022, and ventilation is responsible for over 400 of these. So we'll move on. So again, just giving you the chart. So this is a chart showing the overall measures on the warmer home scheme, and you can see that the highest penalty points by far is external insulation, and that's followed then by gas and roof insulation, and oil would be next. So again, as I said, we'll focus in on EWI for the minute, but we will have a series of webinars focusing in on the other measures over the next couple of weeks and months. So when we looked a little bit deeper at that, so when we go into EWI, why are we having reworks on external wall insulation? And again, you can see, as we said, the biggest driver for that is ventilation. So if we could improve on ventilation, it would have a big difference on EWI. But we've also seen similar issues, so with ventilation across cavity and internal wall insulation as well. So if we could, I suppose, drive improvements with ventilation, it would have a big impact on the overall quality across the scheme. Again, digging a little bit deeper then on ventilation. So why are we seeing reworks in ventilation? So the main reasons would be background vents not installed to standard, mechanical vents not installed to standard, or permanent vents not fitted but required, and again, background vents not fitted but required. So these would be the top 4 reasons why we're seeing reworks in ventilation. And with that said, I'm going to hand you over now to Ronan, who's going to take you through the rest of the slides.
Thanks for that, Philip. Just while I'm sharing, the way I'm going to do this is I'm going to pick up from Philip's last slide, where it, apologies, just sharing the screen, where Philip showed the top 5 reasons for ventilation reworks been picked up, and I'm going to dig a bit deeper into them. So I'm going to go through background vents not been installed to the scheme standard, mechanical vents not been installed, permanent vents not fitted but required, background vents not fitted but required, and vents blocked. And I'm going to show examples of those reworks. Just also to point out, this webinar is the first in a series. The next one we'll do, and it might be in 5 or 6 weeks' time, will be on gas and oil boilers, because that's the next most common rework that are being picked up. We're going to do these hopefully first thing in the morning, and we did a dry run of this last week. So the good news is we're not going to be here much more than half an hour. And the logic is that if we do these first thing in the morning, you'll be able to get on with the rest of your day. And the recordings will be put up online in the contractor support section. So if you are bringing on new staff, you'll be able to show these webinars to the staff, and it'll help perhaps with training of new staff. So first of all, the rules. So what rules do we play by? Is it Part F of the building regulations? Is it SR 54? Is it the DTSS? What is the spec, and where do we get the information from? Well, the answer is it's SR 54, which is the code of practice for the energy efficient retrofit of dwellings, that the information for ventilation comes from. Ventilation isn't new. On warmer homes, we've been installing ventilation since 2015. So it's clear in some cases it's not understood, and in other cases what has been installed isn't being checked. Contractors do need to take ownership of it. Some contractors blame their subbies, but subbies are contractors' responsibility to manage. And our analysis shows that QA is more important when subcontractors are being used. We've produced a Ready Reckoner. We'll walk through it. It covers 90% scenarios, and if it's followed and checked against, it will help to avoid reworks. And the Ready Reckoner has been issued to everybody. So what we'd recommend is that it's printed off and laminated, and that everybody has a copy of it and they can check against it. The consequences are picking up reworks delays you getting paid for homes. It provides additional work for everyone, for yourselves to do the reworks and for ourselves to process the reworks. The homeowner also must accommodate additional visits, and we need to contact them to verify the reworks have been done. So we're annoying homeowners as well. So it's better for everybody if reworks are avoided. So the Ready Reckoner, as I said, get it printed off, get it laminated, give it out to the project managers, surveyors, the ventilation installers, and your QA staff. Ensure it's understood by everybody, including your subcontractors. It's a rule of thumb, but it's presented in an easy to understand format. Refer to SR 54 for the exact spec, but as we said, this will cover 90% of scenarios. So I know it's quite small on the screen there, but you can walk through it. You can look at the room that you're dealing with, and then ask your question against the Ready Reckoner, and the answer then will tell you the correct vent that needs to be put in the room. For example, is it a kitchen? Yes, it is. Is there an open fluid appliance? No, there's not. Well, then it needs a background vent and a 60-litre fan. So there's just one example of it, but it's quite simple and straightforward to follow. So drilling down into the top 5 fails, the first one, as I said, was background vent, not installed to standard. So what we've attempted to do is give guidance here, and the guidance is based on the reworks that we see. So what we've done is we've looked at the inspection failures report, and we've pulled out the reasons that homes are failing. And what we've tried to do then is demonstrate that to you. And if you check against this guidance, it will help avoid reworks. So first of all, make sure that the vent is a certified unit where new vents are being installed. Ensure all the components are been fitted. Like what we say is take it out of the box and put the product in the wall. Don't be mixing and matching. Make sure it's fitted correctly. Make sure it's able to open and close. So what we see commonly with reworks for background vents is they're not able to open and close. Sometimes silicone is used to fix them in position, but the silicone then jams the unit and it can't open and close. And then sometimes our inspectors check to see is the unit opening, and then they pull it off the wall because of the way it's fixed. Some vents have even fallen off the wall by the time we get out there because the homeowner may have pulled it off the wall. If using trickle vents as background vents, just make sure that the requirements of table 31 in SR 54 is met. Make sure the finish around the vent is good. Make good. Leave it as if you'd be happy with it in your own house or your mother or your father's house. That's a nice rule of thumb to have. Make sure that newly installed wall vents aren't ducted to roof vents because then it's not a wall vent. It doesn't meet the standard. So I'm going to move on then with some examples of what we've seen. Like some of these are pretty poor, and I'm sure you'll all agree. So these are examples. Like look at the way the walls left in a house. We can't be leaving people's houses like that. Like there's an example of a vent just wasn't finished. A vent just hasn't been installed properly. It's coming loose off the wall. There's examples then perhaps when the inspector went to open it and the unit just came apart. We see examples of unfinished work. We see poorly fitted work. So look, you can see the examples for yourself there. So just when you're doing your QA, just do your own checks and make sure that you're not leaving work like this. Make sure everything is fitted correctly. Like here's an example where a background vent was put in a ceiling and ducted out. It's not a certified ventilation kit then if that's being done. So the next fail is mechanical vent not installed to standard. So the guidance here is a bit more than the previous one. Make sure that the correct vent is fitted in the correct type of wet room. So going back to my example from the Ready Reckoner, I looked at a kitchen. We know that a background vent is needed in the kitchen and also a 60 litre per second fan. Make sure that a vent is fitted where it's required. For example, a utility room is a wet room, it needs a fan. Make sure that if there is an open fire or a gas fire present, that a fan isn't put in that room because it can affect with the combustion process. Make sure that vents are working. We've seen examples where fans just haven't been wired up and things like that. So do your QA, make sure it's working when you leave the property. Make sure you don't put in, or if DCV is needed, make sure an MEV isn't present. So look, you need to, it kind of brings in air tightness as well. So if the result of the air tightness test is under 5, we know that DCV is fitted, not MEVs. If you can't fit a background vent for whatever reason, you need to submit a technical query for that. But in some cases, like permission may have been given and an overrun needs to be fitted, but then make sure it's provided. Make sure that ducts are insulated in roof spaces or cold areas. Make sure that you use anti-backdraft covers on fans. Don't just leave them permanently open. They need a backdraft fan or backdraft cover. With mini trunk, and if you can minimize the use of it, that would be good. Homeowners don't like it, and we see when we go out to do inspections and BERs that some homeowners are quite unhappy with the extent of trunking used. Make sure the finish around the vent is good. Just make good. Make sure the fittings are fixed to the wall and not loose. Where overruns are provided, make sure that they're set for the correct duration. We had an example recently where the overrun was fitted for 45 minutes. As I said before, do your QA, make sure the fan is wired and is working. Make sure the correct fan is installed in the correct space, so 60 litres in a kitchen, 30 litres in the utility and 15 in a bathroom. Sometimes we go out and we see 15-litre fans fitted in kitchens. Consider the location of the fan. So I saw an example recently of a pump shower or electric shower, and the fans sat beside it, and it wasn't a low voltage fan. So you need to be just making sure that the fan is fitted in the right place. If ducting fans, just make sure the ducting is nice and tidy. And we had another example where there was an MEV fitted in the bathroom, but the switch for it was in the kitchen. So that doesn't really make sense. So if you're fitting a fan in the background or bathroom, make sure the switch is beside the room in which the fan is being fitted. So here's some examples. Again, there's only a few. So ducting there clearly hasn't been insulated. That's an MEV. There's no anti-backdraft damper on it. It's just an open fan. Look, and homeowners do complain then that there's a draft coming in through the fan. Then mini trunk, and look, we've given some examples of it. There's an example of the cover just wasn't fitted. It was just loose. It could be just pulled off the wall. There's a fan that was installed, not ducted. And the next example is ducting in the kitchen. The homeowner just wasn't happy with how that was done. It could have been done tidier. Like, as you can see, it's hanging over the kitchen presses there. I don't know what happened here. There was a core put in for the fan, and then it got put in the ceiling, and the homeowner was just left with a hole in the wall. The next fan was installed in a questionable place, and if you look at the full photo of that, there appeared to be room up higher beside the window. I don't know why the fan ended up getting installed in that location. The position of the fans sometimes we see can be a bit funny. Like on this example, there's a lot of mini trunking, and the fan ends up in this position with the switch for it here. But then when we look outside, we were questioning, look, why couldn't the fan go there? You know, the switch is there, the fan, why couldn't it go on that wall? Look, there may have been reasons why it needed to go there, but I don't know. So just be careful when you're positioning fans and think about the position of them. Like that would have reduced a lot of mini trunking. Again, look, as you can see, this fan obviously is powered from the light switch, and there's an awful lot of mini trunking in place. The next fail then is a permanent vent, not fitted but required. So the guidance is where you have a fireplace or an open fluid heat producing appliance present, make sure that there's a permanent vent present. If there is an electric fire, check if it can be easily removed out to allow a fire be lit, and if it can, a permanent vent is needed. Sometimes a homeowner will request a controllable vent. They'll say to you they rarely use the fire. Unfortunately, that request can't be accommodated. A permanent vent is needed. If trickle vents are present and are adequate, make sure that they're fixed in the open position. If they're controllable when we go out, that will be a rework. Check that rooms aren't open to other rooms. Like sometimes we go out and you might have a kitchen and there's an arch into a dining room or living room, and there might be a fireplace and you mightn't see it, but then that whole space is treated as one and it needs a permanent vent. In this case, it's difficult to provide photos to demonstrate this fail. It's hard to take a photo of something that's not there. So that's why I've just tried to give scenarios. Again, it comes back to doing your survey when you're checking the house and knowing what vent is needed in what room. So understanding the spec will be helpful to avoid these fails. The next one then is background vent not fitted but required. So the guidance on this one is make sure that a background vent is installed in the kitchen. The kitchen is a wet room. It needs a fan, but it also needs background ventilation. And the same goes for utility rooms. Where a Velux is present, it must be able to be opened without the use of a pole or a brush or something like that to be considered a background vent. So it needs to be openable from the ground. If an existing vent is in place, just make sure it's not blocked. If it is blocked, it needs either to be unblocked and made operational, or a new vent needs to be installed. Make sure that vents are put in all habitable rooms. An office is a habitable room. Chances are it might have been a bedroom converted to an office for working from home, but it still is a habitable room. It can be converted back to a bedroom. And again, it's difficult to provide photos to demonstrate this fail. So the last one then is about vents blocked. So the guidance here is just, again, it comes back to checking. It's checking that existing vents are maintained and extended out or replaced where necessary. Look out for suspended timber floor vents. If soffit vents are blocked, the ventilation is to be reinstated, and you might need to use vent tiles to do that. So again, we have some examples here. The first house, you can see from next door there was a suspended timber floor vent in the subject house. It's been blocked. Now there was a suspended timber floor still in place, so that vent needed to be reinstated. The next one then shows soffit vents that were blocked by external insulation. Now, in this case, the ventilation wasn't reinstated up above, so it's just something to watch out for where there's soffit vents. The roof ventilation is compromised by putting in the external insulation, and it needs to be reinstated. The next example is a vent blocked. So this is the same house. As you can see, there's the double doors. And there is a vent present in here in the room, but when you go outside, it's not present. So that vent needed to be reinstated. For trickle vents and windows, and so when new windows are being installed, sometimes they come with trickle vents, and the contractor might choose to put in a window with a trickle vent rather than coring the wall. And that's absolutely fine to do that as long as the ventilation requirements of SR 54 are met. So table 31 of SR 54. The thing is, though, the trickle vents need to have the data sheets to demonstrate that the ventilation requirement has been met. So sometimes like here's an example of a product that is in the window and the contractor has highlighted to say that the ventilation requirement has been met. So the data sheet then must be left in the homeowner pack and uploaded to the database. And in the case of DCV, table 33 of SR 54 is what applies. There are supports there. So for technical queries, they can be sent to Warmer Homes Technical, WHS Technical at ksnenergy.ie. Please provide as much information as possible and include your proposal. Sometimes we just get sent a picture like below, and with very little information behind it. So, like, just try and explain it. Like in this case, look, there's not enough vent here for an MEV and a background vent. A time vent needs to be fitted instead. So if a clear proposal can be put out about what you're trying to do, chances are we'll say yes. We won't go back for more information, and you'll probably end up getting the answer that you want. There are also other supports there from suppliers and manufacturers. So a supplier of ventilation products was in touch with us, and what they were looking for was they wanted to do some direct marketing, I think, to the Warmer Homes contractors. So they asked us for a list of the contractors on the panel. So that information is available. So it's on eTenders. So I was able to direct them to that. So I know they're probably going to be in contact with you to try and sell their product. And we were just chatting about things in general. I mentioned the webinar that we were doing, and we commonly see their products on the scheme. Now, there are other products available. I'm not promoting any particular manufacturer, okay? And I suppose I was wondering, and going back to some of the earlier slides about ventilation or vents coming off the walls, I was just kind of wondering and chatting with them, like if that was a common thing that was reported to them by contractors. So what they said was that they'd circulate a document to us. Now we'll share it with all the contractors after this, but they provided a 5-step plan to effective ventilation. And some of the steps in it are actually exactly what I just covered. So step one is to survey the property for ventilation. Vents need to be maintained or enhanced, and it's take note of trickle vents in windows, excuse me, through wall vents for background ventilation, through wall vents for appliance ventilation. Step two then is to provide the ventilation in accordance with SR 54, both table and 31 and 32, as I would have said earlier. Step 3, ensure there's adequate ventilation to combustion appliances as per table 35. Step 4, you might want to consider sound attenuating vents in noisy situations. Step 5 then, make sure that all vents have the equivalent airflow calculation measured to the standard. To minimize cracking, they recommend to drill a pilot hole from inside and outside and use the core drill from both sides. And I don't know if that will help to reduce the issues that some of you might be having when installing vents. What happens if the plaster cracks? Well, there's a back cover that they will sell to you, I'm sure. It might be neater than some of the examples we've seen. And they have a set of FAQs, and some of these might be useful to have to show to homeowners as well, because one of the FAQs is, can I use a background vent to supply ventilation for a gas appliance or a fire? And the answer is no, any ventilation for heat producing appliances must be fixed open. And we know that, but sometimes it might be challenging getting a homeowner to buy into that. But having this guidance or this document printed out might help, to demonstrate that to a homeowner. So the good news is that's all my slides gone through. So if there's any questions that have come in while I've been presenting, we'll attempt to take them. So I'm just going to stop sharing.
I don't believe there's any questions have come in, Roland. Thanks, Roland and Philip, for that. That was very good. I hope it was useful for everyone. As Philip or Roland said at the start, we're hoping to do these quite regularly, and we want to try and keep them short so it doesn't take up too much time for everyone. So I think, look, as there's no questions coming in, certainly email things into us afterwards if you like. But I think we'll probably close at that, will we, at this stage, guys?
Yep. Thanks, everybody.
One question. Sorry, if a stove has its own air supply, is a vent required? For the purpose of this scheme, I would say yes. What we have to remember on this scheme or for the purpose of wall insulation, the answer would be yes. The principles that Roland and Philip have spoken about there are all the requirements of a wall insulator, what they're required to do. So if someone is installing a stove, they must ensure that they meet Part J requirements. But if someone is installing wall insulation and there's an air supply to a stove, well, then that should be fine in that case. Is there a permanent vent available with a fly mesh? John, I'd say probably go to the suppliers. It's all about capacity of the permanent vents. So I think it's a larger vent with a fly screen. I think a fly screen can reduce up to 50%. So possibly something larger than the standard vent that we use. It could be possible to get one, but I would direct you to your suppliers to ask them those questions. Well, hang on and see. A bedroom has an oil-fired appliance and requires a new permanent vent. But I've been asked if there's a superimposed heart under the carpet. How does that affect a new permanent vent? I'd say that one is fairly specific. So without looking at the details on it, I'd come back to it. I don't know who asked the question about superimposed hearts. What happens if a homeowner refuses a DCV install? Again, that's a specific one, John Paul. I would say contact us on those, you know, keep in contact. Let us know what's happening. If a homeowner won't allow DCV to be installed, there has been very few. We'll always aim to get it in on it, but we will try and work with yourselves, guys, to find a solution there on it. No, sorry, Maria, just on the superimposed heart. I don't know who asked that question on it, but again, that's a very specific one. So if you want to give us a ring on it after, we can have a chat about it. Can trickle vents be retrofitted into windows for background vent or only in new windows? If possible, the key thing is a new vent has to be 6,500 millimeters squared or 5,000 equivalent millimeters. And if the capacity of the vent is satisfactory, if it can be demonstrated that it meets either the equivalent, I can't imagine an equivalent measurement to be given for retrofitting into a window. So I'd say 6,500 free millimeter squared free area. If you checked the capacity of the vent and were able to retrofit that into a window, it would be satisfactory. But from experience, trying to retrofit that in, you'd need a large frame to be able to work on to get it into it. Doesn't seem to be any more questions coming in, so we might wrap up. Thanks everyone for your time, taking the time to attend this morning, and hopefully we'll see from you soon to do the boilers, the gas boiler one. Thanks everyone.
Thanks, everyone. Bye.
Thanks, everybody. Bye-bye.
Bye-bye.